I'm Mitch, and this is my A&P presentation. The paper I chose was called Cerebellar Contributions to Self-Motion Perception, Evidence from Patients with Congenital Cerebellar Agenesis. It's by Dalem, Valko, Schmalman, and Lewis from Rijks University, Groningen University Medical Center in Groningen, the Netherlands. It was published in the Journal of Neurophysiology in February of this year. And again, I'm Mitch Kovacs. How you doing? So first, some background. We know that the cerebellum is a part of the brain that's located on the posterior and inferior part of it. The cerebellum, we learned, was classically involved in rhythmic motions, but in recent years, the researchers have noted that the cerebellum has been found to have some connections to self-motion perception. By self-motion perception, we just mean the ability for a person to tell if they're moving and in what manner they're moving. And that is usually attributed to the vestibular system of the ear. The vestibular system can tell us information on the tilt, which is basically if you lean to one side or the other, or if you're on a boat, you can tell which way you're leaning. It can also give information on linear acceleration. So if you start moving in a straight line, you should be able to tell which direction you were in and how fast you accelerated. And also circular acceleration. Circular acceleration is basically, like in lab, we did the exercise with a chair. If you spin one way or spin the other way, you should be able to tell which direction you're spinning, or if you're spinning at all. So the goal of the paper is to investigate the role of the cerebellum in self-motion perception. And to do that, the researchers found two patients who had an extremely rare condition called cerebellar agenesis, which means that they were never born with a cerebellum. They grew up without it. It's so rare that there have only actually been 10 cases reported since 1998. So you can imagine that these patients are used to research. In a normal person, if you cut out the cerebellum, it would be disastrous. But because these patients had their brains first developed without a cerebellum, the rest of the brain was able to pick up the slack, so to speak, in some ways, but not always. With many people that have cerebellar agenesis, they're actually able to get along in society fairly well. So the researchers used two of these patients, who they called AG1 and AG2, and they took them to their motion perception lab. In the motion perception lab, they were strapped to a moving chair, and the chair would move in some certain way, and the patients were told to report what kind of motion it was. And the patients were also given white noise headphones, and other measures were taken so that they couldn't use external clues or extraneous clues to figure out what motion it was. It should be based entirely on their vestibular system. So the types of motions that they tested were roll, which is just moving or tilting from one side to the other. So like I said, if you were on a boat and the boat tipped to one side, you should be able to tell which way is up. Also the yaw, which is just rotation along a vertical axis, which is to say that if you turn to the left or turn to the right, you should be able to tell which way you're turning. There's also horizontal translation, so in this direction, and there's vertical translation, up and down. The researchers were analyzing perceptual thresholds. The perceptual threshold is the lowest detectable motion. So for instance, if you accelerate really quickly, it's easy to tell. If you accelerate half that, then it would be a little bit harder to tell what kind of motion that was. And if you keep decreasing and decreasing that motion, eventually there's going to be a point where you don't know. It's too slow an acceleration to figure it out. And that moment is the perceptual threshold. So if you have a low perceptual threshold, that means that you can detect very low motion. If you have a high threshold, that means that you are unaware of motions that would be normally detectable. So a high threshold is bad, but a low threshold is good. So they did all these tests on the patients, and they found these results, that the patients across the board performed more poorly on the test than the general population would have. So let's take a look at the first graph, yaw rotation. So the gray triangle and square are the two patients, and the black mark is what the normal threshold would be. So you can see that the two patients had a higher threshold than the normal population for all three of these measurements, which means that they have a harder time telling what kind of motion that was. In the same way, for roll, which is tilting one side to the other, across the board, the patients had a higher threshold than the normal population. Note that AG2, the second patient, was not significantly different from the normal population, but if you average AG1's results and AG2 results, it comes out that it is together significantly different. For Z translation, exact same story, and same for Y translation. So we make the conclusion that the cerebellum is definitely involved in self-motion perception, so much so that the cerebellum, if it is removed, will inhibit self-motion perception. So I have two questions. We learned a few things about the cerebellum, its functions. So what else could be affected by a missing cerebellum? I mean that what functions would be deterred if a cerebellum was taken out? Alternatively, could you guess at what other functions a cerebellar agenetic patient might suffer from? So there's that one, and then my second question is more of a critical thinking. I said that the researchers gave the patients white noise headphones to avoid giving them clues about their motions. So, for instance, they might have been able to hear the sound of the wind rushing by them, and from that they would have been able to tell their motion. So that would have been a confounding factor. The researchers were able to take that out. But what else could they have done? They did do other things that I didn't mention. So what other kinds of clues could there have been that would have acted as confounding variables? Here are my references. The paper and all images were from the textbook, if not taken directly from the paper itself. Thank you for listening.